Hello, this is Mrs. Splenda here, and now we're going to talk about our product properties for exponents. There's a couple of these, so we're going to make sure we go over each one. But before we start that, I want to make sure we know what we're talking about when we are talking about simplifying. So here we are taking a look at our guidelines for simplifying exponential expressions. There's 4 things that I really want us to be taking a look at when we are doing this. Number 1, there should be no negative exponents. None in our simplified answer, okay? Only positive exponents. Number 2, each base should appear only once. That means the large number or the large letter, right? If we have more than one of each base appearing, we have one more simplifying step that we need to do. So each base should appear only one time in our simplified expression. There should be no parentheses. Parentheses are a sure sign that we are not as simple as we could be. And last one, our constants, another name for our regular numbers, should be in reduced fraction form. So if I have, 2/4, I need to make sure I reduce that to 1/2. Okay, things like that. So these are the 4 things that we need to be checking before we say that our answer is in simplified form. Okay, now let's talk about those product properties. So the first one we're going to talk about is called product of powers property. And what we're talking about for that is when I have 2 powers with the same base. Notice that our little guideline over here has an A for the base each time. So this is when I have 2 powers with the same base multiplying. Our shortcut says that I can add the exponents. So if my base is 5 and I have 2 powers multiplying, I can add those exponents, the 3 and the 4, and I have 5 to the 7th power as my final power. And this is because I know, for example, that 5 to the 3rd power means 5 times 5 times 5. And I know that my 5 to the 4th power means 5 times 5 times 5 times 5. Well, how many 5s do I have multiplying all together? Well, I can just count them up. 1, 2, 3, 4, 5, 6, 7. So I can rewrite that as 5 to the 7. So instead of rewriting all my powers out in this expanded form each time, I can just use this shortcut, add those exponents, and I get right to my simplified answer. So I have written a little rhyme to help me remember this. Exponents all in a line. See how our 3 and our 4 are sort of on the same layer? Add to combine. Okay, exponents all in a line, add to combine. So let's take a look at our examples. So over here, I have 7 to the 8 and 7 to the 4th. If I wanted to go the long way and write this all out, I could write this first one as, oh my goodness, 7 times 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 7. There's 8 sevens. And then 7 times 7 times 7 times 7. Well, how many do I have multiplying all together? I've got 8 here and 4 more here. Now, writing those all out is a little bit of work, and I would totally rather skip that if I possibly can. So this is where these exponent properties come in as a nice shortcut. Instead of writing them all out and counting them all up, I can just add those exponents. So let's do that for this next one. Now, we have to remember that when I'm doing this, I'm only doing this for the same base. So that means I'm taking a look at this 3 to the -3 and this 3 to the 4. That 3 is the base. It must be the same. So then I can take a look at adding those exponents. So I would have -3 plus 4, which will give me 3 to the 1. I have 2 others that also have the same base. I have this 5 to the 8 and 5 to the 2nd power. So if I take a look at those, I would have 5 to the 8 plus 2. Well, 8 and 2 is 10. So I can call that my final simplified answer. Remember, you don't actually have to write an exponent of 1. Every number that doesn't have an exponent showing automatically has an exponent of 1. So if I wanted to write this in simplified form, I could write it like that. 3 times 5 to the 10 power, and that would be my simplest form possible. Okay. Now let's take a look at this next one. This one is all letters, so we get a look at what that looks like. And we have to keep in mind, I'm only adding the ones with the same bases. So I will add this exponent. I've got m to the 4. What about my second one? Well, remember, I just said if I don't see an exponent, that exponent is actually 1. So what I have here is m to the 4th power and m to the 1st power. So when I put those together, I end up with 4 plus 1. I will have m to the 5th power. Well, what happens to our other power here, this n to the negative 4? Well, remember last time when we talked about this, we said that that negative exponent means that this power is on the wrong side of the fraction line. So that means what I need to do is drop that n to the 4th power down to the bottom of the fraction line. And there we go. There's my final answer, m to the 5th over n to the 4th power. Okay, so if my exponents are all in a line, I can add them to combine. Let's take a look at our next property. This is the power of powers property. Now, what we can see for this one is that this is a property that happens with parentheses, right? So if we are using our powers property, we're going to see parentheses surrounding a power. And in this case, I've got a to the n, which is a power in and of itself, but that's all raised to the m power. And so when I see a power to a power like this, I actually end up multiplying those exponents. And our symbol for this is these parentheses. We're going to see a power on the inside and then another exponent. That's why they call it a power to a power, right? It's like it's got these little double exponents hanging out. So I'm going to take a look at this. And because I know that I am multiplying these, 4 times 5 gives me that 20. Okay, so got an exponent outside parentheses, then we're going to multiply. Okay, got an exponent outside, better multiply. Okay, now over here, let's take a look at these examples. So I've got 6 squared to the 4th power. So again, I've got an exponent on the outside, so I'm going to multiply these two numbers right here. So 2 times 4 is 8. And now notice when we do this, I'm only multiplying the exponents and I am not touching the base at all. All I'm doing is multiplying that 2 and that 4 and leaving the base the way that it was. Okay. So that's going to happen the same thing here. Oh, look, we've got that 0 power. Let's see if that's going to change anything. What happens when I multiply 3 and 0? Well, I still get 6 to the 0 power, and anything to the 0 power is 1. Well, what if I looked at that 6 to the 0 power and I said, well, that's 1. And then I still had that 3 power on the outside. Well, what's 1 times 1 times 1 times 1? Still 1. Okay, so our exponent rules work no matter which order you're going through them. They're still going to apply and you're still going to get the same simplified answer in the end. So don't worry about which one to use first. They're all going to work out in the same way in the end. Okay, now let's take a look at this last example. Here I've got a little bit more going on. So notice I've got a power to a power over here and a power to a power over here. So let's just do them one at a time. So on this side, I've got an exponent on the outside that I'm going to multiply. So then I've got 3 times 4 gives me 12. And then I'm going to do the same thing with the second half. So I've got, oh, they're negative though. So remember, a negative times a negative gives me a positive. So that will give me a to the 6th power because negative 2 times negative 3 is 6. Now I again have two powers that are multiplying. This is the situation we just looked at before. Our exponents are in a line, so we will add to combine. So I've got 12 plus 6. My final answer will be a to the exponent 18, so a to the 18th power. And that is my final simplified answer because there are no parentheses and the base appears only one time with positive exponents. So we know that that's our simplified answer. Okay. All right, we've got one more of these to take a look at. And this is the powers of products property. Now, this is when I have more than one base multiplying on the inside. So right here, I notice I have both a and b, and so I need to bring that exponent to both the a and the b in my final answer. And so it doesn't matter if it's both letters or both numbers or whichever, we need to sort of distribute that exponent to every base, right? So if there's more than one base on the inside of those parentheses, everyone joins in the fun, okay? More than one, everyone joins in the fun. So for my first example here, I've got 4p, and that's all raised to the third power, okay? So everyone gets to join in the fun, and now everyone has that exponent. That's all there is to it, okay? Now, for this one, see how I've got negative 5t squared all squared. So because the negative 5t squared is inside the parentheses, that means the negative 5 is what is going to be squared. So because it's negative, I'm going to parentheses it so that I know that that negative 5 is the whole base. And then I will also have, oh, look, I've got a power on the outside. So now I need to think twice. Not only does this exponent come in, but I need to multiply those to get my final power, okay? So we're combining the two that we've seen before. All right, and our next example is a little bit longer, but we're going to take it one step at a time. I'm going to work with this first group, and then I'm going to work with the second group one at a time. So for this first one, I see that I have a power on the outside and more than one, so this power will come into each one. So I will need to multiply this power with that power, right? Exponent to exponent and exponent to exponent. So I will have 2 times 4 is 8, and y to the 3 times 4 is 12. So that's my first expression. And then we're going to take a look at the second half. Same thing. I've got this exponent on the outside that will need to multiply to each one on the inside, more than one. Everyone joins in the fun. So I've got 2 times negative 4 gives me negative 8. And 4 times negative 4 gives me negative 16. Okay, now I've got 2 ways that I can go with it. I can go ahead and take these negative exponents and drop those powers down to the bottom of the fraction line. Or since I see that my powers are all in a line, my exponents are all in line, I can add to combine these. So I'm going to go ahead and add to combine in this case, because that's a rule we've already talked about. So if I have x to the 8 and a negative 8, when I add those, I'm going to end up with x to the 0. And let's take a look at our other one over here, my y's. So I've got y to the 12 and y to the negative 16. So when I add that negative 16, I'm going to end up with y to the negative 4. Okay. So I'm not yet done because I see, for example, I have a negative exponent. So if I have a negative exponent, I'm not as simple as I can be. And I see I have x to the 0. Anything to the 0 power is 1. The negative exponent means that power is on the wrong side of the fraction line. It needs to drop below, and then we're good to go. Okay, I've got each base appearing only one time, only positive exponents, and no parentheses. So that is my final simplified answer, 1 over y to the 4th power. Okay, so the steps can get a little bit longer, but if we just take them one at a time, we're still going to get to a nice simple answer in the end. Okay, all right, now I've got a couple of these where we're going to more than one rule together. Okay, since we've talked about several now, I want to make sure that we remember each one. Okay, now see for this first example, I can see that I have all of my exponents sort of all in a line. So this means that this is where I'm adding to combine them, but I have to make sure I'm only adding the ones for the same bases, okay? So let's take a look at these m's. There we go. That's the same base. So I will have m to the 7, and then we're going to add this 2 in the middle, and then we're going to add this 3 on the end. And those are all the exponents that we will add to combine. Okay. Then I see I also have some n's. So let's take a look at those. Now remember, if I don't see an exponent, that really means it's got an invisible exponent of 1. So I want to think of that as n to the 1 plus this 8 over here on the end. Okay, well, what about our numbers? What am I going to do with them? Well, this is just a multiplying problem, so I'm just going to multiply the numbers. They don't have any exponents, so they're not going to follow our exponent rules. They're just going to follow our plain old multiplying rules. So 3 times 5 gives me 15. And then 7 plus 2 plus 3, I end up with m to the 12. And 1 plus 8, I have n to the 9. Okay, let's check. Any negatives? Nope, no negatives. All my bases are only showing 1 time, and my numbers are as simple as they're going to get. I think we are good to go. That is our simplified answer. Well, let's take a look at this next one over here. And again, I see I have a couple of different things going on, but no powers on the outside to worry about. My exponents are all in a line, so I'm just going to combine them. So I'm keeping in mind, I'm looking for those bases that are the same and adding to combine. Looking for those bases that are the same. If I don't see an exponent, I need to remember that it's an exponent of 1. And in this case, I have a negative exponent, so I want to keep an eye out on that one. So I've got a to the 4 plus 3. 4 plus 3 is 7. And then I've got b to the 1 plus negative 6. 1 plus negative 6 is negative 5. Uh-oh, I have a negative exponent. That means we're not done. Remember, that negative exponent means that power is on the wrong side of the fraction line, so I need to drop him down below. There we go. And now we're all done. I have each base showing only 1 time, no negative exponents. That's our simplified answer. All right. Let's take a look at our last 2 examples here. I've got some A's and B's on the left. So again, I want to make sure I'm taking it one step at a time. I see I have an outside power here that I'm going to need to bring into everybody on the inside. And so I'm going to multiply that negative 2 with the 4. And I'm going to multiply that negative 2 with the 0. Well, negative 2 times 0 is still going to be 0. And this second one does not have an outside power, so I'm just going to rewrite it like it is. Now, as I'm writing this, I'm seeing one thing that I can take care of in this next step. Anything to the 0 power is 1. Anything to the 0 power is 1. So instead of having a to the 0 times b to the 4th, I just have 1. And so now what I'm really looking at is I only have this a to the negative 8 and this b to the 4 to worry about, because 1 times 1 times b is just going to be b. Now, I've got that negative exponent. It's telling me the a to the negative 8 is on the wrong side of the fraction line, so that means he has to drop down below. But once he's there, now it's a positive exponent, and we are good to go. Okay. Now you can take care of these 0 powers anytime you see them. For example, in this last problem we're going to do, this last expression, when I see that y to the 0, I can just think to myself, well, that's going to be 1, and take care of it in that first step rather than waiting till later. You can take care of it anytime, okay? And I know that 2 times 1 is just 2. And so I've already got that first expression as simplified as it's going to be. So let's take a look at the second one. I've got that power on the outside, so we need to multiply. So I'm going to have negative 3 times negative 2 gives me a positive 6. And so I see here that I've got, I've got 2x cubed times y to the 6th power. Well, I've got no common bases. I've got nothing repeating more than 1 time, and I have no negative powers, so that is as simple as it's going to get. There is my simplified expression for that one. And that is a reminder of how all of our product properties work.